So for these algebraic ones, there's a couple of different ways that we can go about it. Okay? If you're using the formula for part A here, the formula says that NP2 is equal to n factorial over n minus 2 factorial. Okay? So then NP2 equals 56. What you would do for showing your work is you could take the NP2 and change it to n factorial over n minus 2 factorial is equal to 56. And now we have to simplify this. Now simplifying factorials is one thing when they were numbers. So if I had numbers, 8 factorial over 6 factorial, you would notice that, well, 8 factorial means 8, 7, 6, 5, 4, 3, all the way down to 1, right? So I could expand both of these, or can you see that if I'm going all the way down, I could get to 6 factorial and say, hey, wait a second, all of those are going to cancel from there. I could write them all out all the way down to 1, but I don't have to, because once I get them to be the same, they'll go away. Now you can do this with variables as well. The hardest part is looking at your variables and making a decision which is bigger. Is n factorial bigger or is n minus 2 factorial bigger? It's not that hard, but sometimes it will catch you and you'll start expanding the wrong one. Which is bigger, n factorial or n minus 2? N, right? Because the other one is 2 less. So what we do is we do the same thing we would do with numbers. We start expanding it. Well, when I start expanding it, well, it's going to be n times what's 1 less than n? N minus 1. And then what's 1 less than n minus 1? N minus 2. And once I get to the one that's on the bottom, I'm going to say, well, I'm not going to keep going all the way down to 1, because just like I had up here, once those two are the same, they'll cancel each other out because they're identical. And they'll simplify to just be 1. So I can say this and this will simplify to just be 1. And then my question just becomes n times n minus 1 is equal to 56. What kind of question is this? It's a quadratic. So how do we solve quadratics? Well, we'll multiply this out. N squared minus n, bring the 56 over, and factor n minus 8, n plus 7. So our two possibilities are n equals 8 and n equals negative 7. Now our definition of factorials is factorials make sense when they're positive whole numbers or 0. If we go back to our original equation here, we're going to see that this one's not going to make sense, because in our original equation we would have negative 7 factorial. And we don't have a definition for negative factorials. Yes?
Then put the NMS as the solution.
You just have to say that it is an extraneous root. Okay? So we got n equals 8 as our solution here, and that's one way to solve it. This is the way you'd have to solve it, because often these questions will say solve algebraically. They don't want you to just guess and check, because your answers are whole numbers, so it doesn't take you too long before you guess and check the right one. Okay? The other guess, if you are guessing and checking, the best way to do a guess and check here is say, well, this is the number of choices, and what did the second number stand for? Number of spaces. Can you think of two consecutive numbers that multiply to 56? 8 and 7. So n has to be 8. So for these ones, if it says solve algebraically, then you're going to have to go through that process that we just did. If it doesn't say that and you're allowed to solve it anyways, you could just say, well, I know that NP2 means that there would be 2 spaces, and they have to be consecutive numbers because it goes down by 1, and 8 times 7 is the only thing that works. Now, for 5p3, if we're going to our formula, this means 5 factorial over 5 minus r factorial is equal to 20. And we don't have an n in the top and the bottom. And there isn't a way to simplify this one. In fact, this is one where the best method for solving it is the idea of spaces. What do we know? We know that we have 5 choices to start with. So if we are going about our spaces, if we had only one space, we would have 5. Is that equal to 20? This isn't a trick question. No, good. Okay. If I added another space, the next number would be 4. Is that equal to 20? Yes. So I know that r has to be 2. And that's how you would do ones like this. There isn't an algebraic way to solve for this nicely. You know that the r, only possibilities for r, because a factorial can't be negative, are somewhere between 5 and 0. But the spaces allows you to figure it out easiest and quickest. Yes? Yeah. So question you can do for this one is number 10.